Okay, welcome back everyone. So this is a solved example problem of Newton's second law in one dimension, and this is number 38 on page 133. So I'm not going to write the whole problem out, so go ahead and grab your book and crack it open if you want to read along with me. But it says the engine of a 1 kilogram toy plane exerts a 15 Newton forward force. If the air exerts an 8.0 Newton resistive force on the plane, what is the magnitude of the acceleration of the plane? Okay, so here's the plane. Okay, there's a wing, there's another wing, toy plane. Okay, so the engine exerts a forward force of 15 newtons. So we'll call that F engine, and that's 15 newtons. Okay, and the air exerts an 8 Newton force, so call this F air, and that's going to be 8 newtons. And that's going the opposite direction, so we may as well put a negative sign on that. And we want to know the magnitude of the acceleration of the plane. Okay, so you may not recognize it as such, but I'm actually doing four-step problem solving method. First step, draw a picture, identify the knowns, identify the unknown. In this case, it's acceleration. Second step, find the right equation. F net equals mass times acceleration. Now we have to be careful about this. In every single force problem that we do, we want to make sure that we correctly identify a positive and negative direction. So most of the time, going to the right is positive. That works just fine. So then when we say the net force, or the sum of the forces, we really do need to look at the direction. And in this case, it would be 15 newtons would be positive because it's to the right, and 8 newtons would be negative, going to the left. We have a mass, whoops, forgot to write that down, of 1 kilogram for the toy plane. And then we're trying to find the acceleration. And just as a quick aside, in the equation F equals ma, we are talking about units of newtons, kilograms, and meters per second squared. So that's kind of the definition of a newton, is 1 newton is 1 kilogram accelerated at a rate of 1 meter per second squared. Remember that we can also talk about weight as a force. A good example of an object that has a weight of 1 newton is a quarter pounder with cheese. Hungry? Okay, so now back to our problem. So the net force is going to be 7.0 newtons. We'll just keep two sig figs, and that's equal to 1.0 kilograms times acceleration. Okay, pretty easy math here. I didn't choose the problem for its math difficulty. And we get an acceleration of plus 7.0 meters per second squared. So in other words, the plane is accelerating to the right at a rate of 7 meters per second squared. Just as a review, that means that every second its velocity is increasing by 7 meters per second. And that's pretty much it.